Hello guys, my name is John Michael Reyes and this is the tutorial for chapter 8. The chapter 8's name or characterized is subnetting an IP network. First, let's see the preview of the chapter 8. Designing, implementing, and managing an effective IP address plan ensures that network can operate effectively and efficiently. This is especially true as the number of host connections to a network increases. Understanding the hierarchical structure of the IP addresses and how to modify the hierarchy in order to more efficient meet routing requirements is an important part of planning an IP addressing scheme. In the original IPv4 addresses, there are two levels of hierarchy, a network and a host. These two levels of addressing allows for basic network groupings that facilitate in the routing packets to a destination network. A router forwards packet based on the network portion of an IP address. When the network is located, the host portion of the address allows for identification of the destination device. However, as network grow with many organizations adding hundreds and even thousands of hosts to their network, the two-level hierarchy is insufficient. Subdividing a network adds a level to the network hierarchy, creating in essence three levels: network, subnetworks, and host. Introducing an additional level to the hierarchy creates additional subgroups within IP networks that facilitates faster packet delivery and add filtration by helping minimize local traffic. The chapter examines in details the creation and assignment of IP network and subnetworks addresses through the use of subnet mask. First of all, this chapter 8 is all about the subnetting, and it is how we're gonna do the IP addressing and other stuff. It is connected with the chapter 7, the IP addressing, but it is much more broad or more on computing than chapter 7. So let's begin. Hello guys, first of all, this is one of the major things in the chapter 8, the subnetting based host requirements, because as you can see, the variable or the in binary conversion, it is different from host requirements because excuse me for that. In host requirements, the first number is not 1 but it is 248. I mean, just like that, it's upping by 2. Then the number of host address required for each network, then the number of individual subnets needed. The table in the figure displays the specific for subnetting a /24 network. Notice how there an inverse relationship between the number of subnets and networks of hosts. The more bits borrowed to create a network, the fewer host bits available. If more host addresses are needed, more host bits are required, resulting in a fewer subnets. The number of host addresses required in the largest subnet will determine how many bits must be left in the host portion. Recall that 2 of the addresses cannot be used, so the usable number of addresses can be calculated as 2 raised to n minus 2. That's the formula for calculating the usable host of I network or address. Then, as you can see in here in the figure, the prefix is /25, then the host number is 126 because of the, and there will be always some adding of subnets if you borrowed bits. Then let's proceed. After that, subnetting based on network requirements. It is somewhat, if you need a 128 host, then 64, then other stuff. Just like this one, the other one, if you need 126, 62, 30, you need a /25, 26, 27, 28. Then after that would be network requirement example. It is somewhat just like this one. Then as you can see, you need a 40, 30, 35, 40, 35, 30, 23, and 10 hosts. So first world, you have a IP block of 172.16.0.0/22. Then in order to have a net 17, you should have a /26 in order to have all those three accommodations for all the hosts they need. And then as you can see, there's already an IP address in every host or networks or subnetworks that it has. Then as you can see, it's just like in the chapter 7 activity or tutorial. We're just gonna translate this to a subnet mask. Then let's try. First this 111, 111, 111. Oh, it's not 110. It would be 111. Then 224 is 1110000. Then after that, oh, sorry for that. The prefix notation would be 24 plus 7/27. Then as you can see, it is correct. Then it is just pretty simple to do because you will just add this. As you can see, is 1 2 4 1 2 4 8 16 32 64 128, and if it is all added, it would result a 255 decimal value. Then that's all for this first activity. Then let's go to another one. Then guys, this is the second activity, or I'll gonna teach you how to answer this practicing VLSM. Then we all know how to compute the VLSM because of the first activity or the instruction that I've shown you in the first part of the video. Then we all know that chapter 8 is focused on VLSM and having a subnet of IP or networks. So let's try to answer this. Then network subnet mask, that would be a 255.255.192, because as you can see, there are no subnet mask in here other than this one. Then the prefix notation is /26 because there's no other notation in here prefix. As you can see, it's just all IP address and one subnet and one prefix. Then first full subnet range, the first one will be this one because as you can see in here, it is 0.0 and 0.63. Then the second one would be 0.64 to 1.27. Then the other one would be 127. Then this one. Then after that, let's check. So you can see my answers are all correct. Then let's see second subnet range. So subnet range would be, as you can see, we have no other subnet range in here. Then no others. New VLSM subnet mask, or I mean in here. Then the VLSM subnet mask would be this one. Then second full one would be this one, then this one, then I think it's this one. Oh, not this one, then it's this one. Then as you can see, it's just pretty simple and easy to do. So let's proceed to another one. And guys, since VLSM is a huge part of the chapter 8 topic, so we're gonna master, or somewhat I'm gonna tutor or teach you more about the basic VLSM. Then as you can see in here, there are tables of basic subnetting, but first let's know what is VLSM. The VLSM is a somewhat variable subnet length. Subnet mask is somewhat used in every network that uses subnets and other stuff. Then subnetting is, then let's talk about this one, the table. Then to better understand the VLSM process, go back to the previous example figure in 1. Then as you can see in here, then was subnetted into 8 equal size subnets. Then 7 of 8 subnets were allocated, 4 subnets were used for the LANs, and 3 subnets for the WAN connection. Then as you can see in here, this one are the subnets, and for ones, then ones are somewhat the serial, I think. Then the other one would be to create smaller subnets of one links. One of the subnet will be divided in this example. The last subnet 192.168.20.224/27 will be further subnetted. Then as you can see, it is further subnetted in order to have some ones. Then recall that the number of needed host address is known for the formula 2 raised to n minus 2, so it would be slash 30, not slash 32, because slash 30 is it has two, I think it has 8 subnets, so it 8 usable hosts, so it can accommodate the subnet mask or the ones. So then because of there are 5 host bits in the subnet 192.168.22. For addresses by 3 more bits can be borrowed, leaving 2 bits in the host portion as shown in the figure 2. The calculation at this point are exactly the same are those used for traditional subnetting. The bits are borrowed and the subnet range are determined. This VLSM subnetting scheme reduces the number of addresses per subnet to a size appropriate for the one subnetting. Subnets for once allows the subnets 4, 5, 6 to be available for future network, as well as 5 additional subnets available for once. So as you can see in here, you can't make or build a network if you don't know how to use a VLSM. Yes, you may build one, but you can't connect each other. It may fail, it will always fail because there's no IP address, and somewhat your you don't know how to do a VLSM. You can connect each other, you can just build it, but you can't connect it. And that's all for chapter 8. Thank you, and thank you for listening for my teaching, and goodbye.